This is chapter number 2, Structure of Atoms, and the topic is Bohr's atomic theory. So what are the learning objectives in this topic? Rutherford's contribution. Definitely it was Rutherford's contribution on which all the Bohr's atomic theory was based. And how fixed orbits have the fixed energies? What is angular momentum as electrons are revolving in circular paths? So definitely they possess angular momentum. At the end, how mvr is equal to nh over 2 pi, or angular momentum is equal to nh over 2 pi. So here we go with it. Rutherford told that nucleus is a dense positive portion which attracts electrons towards itself. And as electrons are negatively charged particles, they are accelerating and radiating energy. As electrons are losing energy, a time comes when it falls down into the nucleus. An atom will collapse. But in actual, it doesn't happen. If it happened, we don't have any single atom today. So Rutherford didn't give any information about the stability of an atom. Then in 1913, Bohr put forward the theory, and he gave a very general postulates about the orbits of electrons. According to him, electrons are not moving in any of an orbit. Electrons will not choose any of the orbit because there are infinite orbits present around the nucleus. It will move in only allowed orbits with quantized energies. So those orbits are called discrete orbits. Like here, orbit number 1, 2 and 3 are shown. These are allowed orbits with quantized energies, or we can say them fixed orbits with fixed energies. Until or unless electrons remain in allowed orbits, they will not release or gain energy. So definitely when they are present in their orbits, they are not radiating energies. So how they will fall down into the nucleus? Electrons will only gain or lose energy when they jump from one orbit to another orbit. So in this way, Bohr explains the stability of an atom. For example, here this is an electron and it is revolving around the nucleus with velocity v, and this is the distance between the electron and nucleus, which can be represented by r. So in this way, this will be equal to angular momentum. Bohr also told that angular momentum of any orbit can tell us about the energy of the orbits. The orbits which are closer to the nucleus have least energy, and the orbits which are far away from the nucleus are higher in their energies. So in this way, he also explains the features of orbits. Electrons will radiate energies or gain energies in the form of photons. So the energy emission will take place in the form of photons. Now let's discuss about the postulates of atomic theory and how angular momentum is equal to nh over 2 pi. Bohr says that angular momentum is equal to nh over 2 pi, where h is the Planck's constant and its value is 6.63 multiplied by 10 raised to power minus 34 joule second. So here the number n, the symbol n is representing number of shells, and if I put the value of number of shells, I can get the angular momentum of any of an orbit. So in this way, Bohrs explain the angular momentum of the circular paths of orbits in which electrons are revolving. Here hydrogen is taken as an example. The hydrogen atom consists of a tiny nucleus and electrons are revolving in one of circular orbits of radius r around the nucleus. Each orbit has a fixed energy that is quantized. So the electrons are moving in discrete orbits. The second postulate is that the energy is emitted or absorbed when an electron jumps from one orbit to another orbit. And when electron jumps from lower orbits to higher orbits, it absorbs energy. And when it jumps down from higher to lower orbits, it radiates energy. The change in energy will be equal to delta E is equal to Planck's constant and frequency. So where the value of Planck's constant is 6.63 multiplied by 10 raised to power minus 34 joule second. Angular momentum of orbit can be found out by L is equal to NH over 2 pi. Now if I talk about shell number 1, we have to put 1 at the place of n. So by putting the values of Planck's constant 2 and pi, which is 22 by 7, we can get the angular momentum of shell number 1. And in a similar way, if I put 2 at the place of n, it means that I am talking about shell number 2, and it will give us the angular momentum of shell number 2. Similarly, so on. In this way, the angular momentum can tell us about the energies of orbitals, that how energy change occurs during the shells when electron jumps from one shell to another shell. Thank you so much.